æsir eyjaber, úr gumlaminn hryðjum, staðsett þessi eyja á Atlantshryggnum miðjum. Þar reiddust ágæt fólk, urðu sviðnar grundir, fjandinn sjálfur fékk sér skjól, fjallinu Heklu undir. En þá gerast undur stór á ísaköldu landi, og þau mest úfinn sjór, eldi, spýr og sandi. Gerðist slíkt við gerfuglsker, grúði myrkur og bárum, eina nótt í nóvember, nú fyrir 2 árum. Af þessu varð eyjan í undan suðurströndum, regnin fætum borð og vín, trýn hækkuðu á löndum. En Bretum illa brá hér við, bregðast heitinn vina, fjandann með sér fá í lið, til að færa út landhelgina.
Hidden by oceans, a crack is opened across the earth. It scores the line of a submarine ridge around the world. It is not mending. The fracture is kept active by the upthrust of matter from within the earth. The ultimate danger is unguessable. Its immediate threat is the earthquake and volcanic activity which escapes out of that rift. The part of it along the mid-Atlantic ridge has given vent to 4 outbursts in a decade. In the Azores in 1957, Tristan da Cunha in 1961, and in the same year in Iceland, Askja came up like a boil. The central fissure is out of water and visibly dividing Iceland. Indeed, Iceland is slowly falling apart along the rift. Invisibly, the rift continues under the ocean to the north and to the south. The islands off the south coast of Iceland are cold, dead volcanoes. Here, islands have boiled up and inevitably subsided again beneath the sea before they could be named, unless they produced enough lava to resist the sea. The small islands are the rock-lined throats of what were smoking pipes from the erupting crack. Only one large island was able to grow, resist, continue, because as it formed, it advanced into the sea a breakwater of hard cooling lava. Behind these stone walls, the island was secure and hospitable. These walls were built by an upthrust through the cracked earth when Mount Helgafell coughed up enough lava to create an island of 6 square miles, which has lasted 6,000 years. Healthy, hardy as they seem, the people of the island are different. The life they lead is different. In the background is always the reminder, the threat of what surges beneath them, so they build their houses of concrete and wait quietly, but not in ignorance of that background. Even fishermen know that beneath their familiar element of water, a fire is burning. And they were fishermen in a small boat laying lines in sight of Mount Helgafell who were the first to recognize the new volcano. On November 14th, 1963, the bubbling crack in the earth opened for the 4th time in a decade. The eruption cloud had already reached a height of 10,000 feet when observations, measurements, records were begun by geologists the first morning. The eruptions, which varied in number during the day, were issuing along a lengthening fissure. It was a submarine volcano, an explosion caused by the intrusion of cold seawater into the hot, narrow crack. Steam and tephra burst out. The ocean at that point was 425 feet deep. The fissure grew until it was an unbroken 600 yards. Along the entire length of it, the eruption issued. 14 miles away, the threat to the islanders rose from the possible contamination of rainwater, the threat for the fishermen in the spoiling of the sea by heat and the deposit of tephra. The next day and the days following, the tephra deposit accumulated rapidly. A steady wind from the north all through November caused the porous deposit to be laid on the lee of the new island, while the sea beat it away on the windward and forged a horseshoe. The sea continued to pour into the single vent. The violence of a wet explosion is due to the propellant power of steam, and tephra is formed when lava and water meet, fluid magma being suddenly particularized. Deep explosions shot up vertically, sometimes to 500 yards. Shallow explosions occurring in the wide muzzle of the vent were aimless and formed cock's-tail columns. White and black separate in mid-air as the plumes of steam and the heavier ash fall at their different rates. Interest in the phenomenon from the United States was due to Professor Paul Bauer of American University. Many interests converged on the volcano.
Volcanic lightning is of mild interest to geologists. So are tornadoes formed by the volcanic heat for meteorologists. These are excellent conditions in which to examine the behavior of a troublesome occurrence throughout the world. The fallout of tephra which accompanies them is a phenomenon of interest to chemists, among others, and a rare chance. A boat had only to sail downwind to collect on her deck samples of the substance which constitutes the Earth's crust. That it washed away easily was a reminder that the island, too, could be washed away just as easily. Would it last long enough for study was everyone's concern.
One vent had closed, another had opened. Despite its height of over 500 feet, the island was impermanent and kept losing ground to wind and water. But in 4 months, the volcano produced over 500 million cubic yards of tephra, and the lightweight island grew. Fire was first observed in February. The uprush of tephra from a vent at sea level blocked the sea from a higher vent in the same fissure. The effusion from the dry vent was, for the first time, a fountain of viscous fire. Bombs as big as cars sometimes, steam-propelled and burning, kept observers at a distance. Energy was being released at the rate of 10 to the 18th ergs per second, enough energy to illuminate a city 10 times the size of New York. If these were lava fountains, the island might last. The fire died after 5 days and 5 nights.
Next trip was somewhat more memorable. It was on February 19th. We wanted to go out, some scientists and some journalists, to have a closer look at the island, take samples and so on. I had been in a reconnoitering plane over the island the day before, and then there was a breach in the crater wall, and the sea flooded the crater. Under those circumstances, it usually kept rather quiet, and I decided that there was no real danger in going ashore. Went from the Westman Islands in a small fishing vessel.
For Professor Sigurður Þórarinsson, an Icelandic volcanologist, 3 months of observations from a distance had been frustrating. Professor Þórarinsson's first observations had been on the volcano's first day. He was hopeful of collecting rock samples from the island. The February sea was heavy, and far more than the volcano caused them anxiety. The life belts proved wise but unnecessary, though one dinghy capsized as it beached. But the party could be seen from the boat, and shortly they reported all hands safe. The tephra cloud obscured the landing party and silenced their remaining contact. Whatever had happened to the party, no rescue could have been attempted.
I remember one of the girls making the remark that there are no overwhelming odds against some of these bombs hitting your head, and I guess that was true. But we had not been on shore more than a few minutes when the big crater fired some warning shots, and we heard the bombs falling out in the sea outside the island, and then they started to crash down all around us. The fishing vessel had to go away because of the bomb fall in the sea. So we were 7 on shore, 5 men and 2 girls, and under those circumstances you have to try to overcome instinctive urge to take to your heels, but the only correct thing to do is just to stand still and stare skywards and not jump aside until just the bomb is going. You feel that the bomb is just going to land on your head, then you jump aside. And then came showers of ash in between, so it was completely dark. It was lukewarm though. There was some lack of oxygen in these clouds, but the wind was fortunately strong, so they blew away very fast, so you could breathe again. This went on nearly an hour. Ash showers, and then bomb fall, and ash showers again.
Ýmsir töldu óvíst þó örlög hennar vera uns hún hrauni úr sér spjók sem fjöll stundum gera. Byði hún úr bruna þá borg á nokkrum dögum víst sem hana verja má gegn ægislögum.
The breakwater against the sea was formed in April. The future of the island was certain. It would be secure and hospitable. It would have a place on maps of the world. It would have a name. Surtsey would be called the island of Surtur, the fire giant. Separated from the sea, Surtur became an effusive volcano. In Norse mythology, after Surtur's fire destroyed all earth and heaven, the world was born anew. All evil perished, that from the ruin goodness might rise again.
We had later on to go down into the crater itself, and this was at time rather hazardous. Because of the splicing of the hot lava. We had several burns. It was nothing serious, but the worst thing was that the gases were so aggressive, both to your eyes and especially to your lungs, that working down there was rather unpleasant, of course. There were 3 people sampling gases down there in the crater for about 4 hours, 3 or 4 hours, and they were suffering for 2 days afterwards from vomiting and headaches because of the poisonous gases. It was on one of these trips that we went into the crater, and I had to put my rucksack, put it on the lava. It was okay to stand on it and go my rubber boots. But I was looking at the fire and didn't notice my bags, but then when I turned around and saw it, it was a flame. Then a little later on that same trip, my cap caught fire also from a little piece of lava which got caught in it. As we were sampling.
Professor Guðmundur Sigvaldason analyzed the chemical composition of the lava. It was the same as the earlier tephra, an olivine basalt. The highest measured temperature was 1130 degrees Celsius. What might the temperatures be inside the Earth? The lava dome increased in height continuously as the lake splashed, cooled, hardened. The development of a shield volcano or Hawaiian type had never been witnessed. The lava lake rose inside the growing dome. The surface had reached as high as 365 feet by July. When the lake level rose, it could be watched vigorously brimming over in rivers of flowing rock. At 45 miles per hour, the lava flows faster than a man can run. The seething rivers frequently enter tunnels. The molten rock splashes the sides of the channels, clings, cools, and slowly covers itself over, though the course is still visible from above. shell of hardened lava is spread over the island, and through porous tephra are everywhere tough veins of bubbling rock.
Well, the composition of these gases are quite interesting. The main constituents of the gases are hydrogen and sulfur dioxide, with carbon dioxide, some carbon monoxide, and water. Water amounts to about 80% of the whole gas mixture. This composition is quite similar to gas compositions of the Hawaiian volcanoes.
In hot torrents, all the streams urged up by the central vent move to north, south, east, and west, pulled down by their own weight. Pseudo-eruptions occur when lava meets the sea. Tephra sand piles up at the lava edge as the island irresistibly expands outward into the sea. Lava congeals rapidly when it hits cold water. Cinder forms, which the sea breaks down into black sand. More lava covers the sand, and the shore is persistently extended beneath clouds of steam. How much lava was poured into the sea is unmeasured, but the area of the island by the end of August was a mile square, an area traced and retraced as its size was taken. Visitors to Surtsey had soon to be restricted. Curiosity was a sufficient passport, but it had to be curiosity with a purpose. Those who qualified were curious about many things, for no one had ever seen anything like Surtsey before, and some, like Professor Thorarensen, had seen it all happen.
One of the more remarkable things when you come on this island, how fast the geological processes work there. We are accustomed to this in Iceland, though, because everything in Iceland, from a geological point of view, goes very fast. Iceland was built up in a very short time, and both the building up forces and the forces that break down, they work at a very great speed in Iceland, but in Surtsey they work at still greater speed. Things that happen here in, say, 100 years, they may happen here in a few days. The lava flowed down into the sea And then you have a gentle slope when the lava goes down into the sea. After a few weeks you may have vertical cliffs, many tens of feet high, and in front of them you have a sandy shore, and around the pebbles and blocks just surrounded that you would guess that they were thousands of years old. Just that you know that they are only a few weeks.
The desert shores then showed something more wondrous than a human footprint. There was death on Surtsey Island. And where there was death, there was the fertile promise of new life. And where there is life and death, there is man to be curious and hopeful. And the observations, measurements, and records began again.
Sustur hann hljónaður, ég hygg hann þögull lífi, þótt sonurinn hans yrklingur, sífellt kjaftinn rífi. Þarlegt vann hann verki hér, víst að gleður líði, Surtsey stórmerk eyja og Íslandi til fríði. Þann skal botninn berja nú, í braginn minn hinn ríka, að og verður eyja sú, yndi jarðfræðinga.